Hello, students. So, in this activity, we're working on creating graphs and identifying characteristics and using the table to do that. As you get better at this, you will notice some shortcuts that make you able to graph the quadratic a little quicker without plugging in all the x values. But I want you to remember that every graph is really just a picture of all the x values that got plugged in. So, while it may feel nice to use the shortcuts, what you are always doing is plugging in the x values and plotting the points where the x and the y values are based on the equation. So we'll do a couple. I'm going to skip through a few of these. First equation, y equals x squared. So I take each x value and multiply it by itself. Notice that when I multiply a negative times a negative, I get a positive answer. So when x equals negative 2, y equals 4. When x equals negative 1, y equals 1. And that's where I'm placing these dots over here. Where x equals 0, y equals 0, and where x equals 1, it's 1, where x equals 2, y is equal to 4. So all I did there was took each of the x values and multiplied by itself because that's what squared means. The vertex is the place where the graph turns around, so that's 0, 0. AOS is axis of symmetry, that's the mirror, that's the fold line, x equals 0. And does it have a minimum or a maximum point? This has a minimum point. By the way, this graph right here also has an x-intercept of 0, comma 0, and it has a y-intercept of 0, comma 0. This is called the parent graph. Everything is essentially equal to 0 on this, and 0 is the most important number. Let's move on to one that's a little bit trickier. I'll actually talk through the operations on this one, but all I'm doing is taking each x value and running it through the equation. Parentheses first because I'm plugging in. 0 minus 2 is negative 2. Square that, I get positive 4. Add 3, I get 7. My y value is 7. Now if x equals 1, 1 minus 2, negative 1. Square that, positive 1. Plus 3, positive 4. Next up, 2. 2 minus 2 is 0. Square that, 0. Add 3, 3. Next up, x equals 3. 3 minus 2 is 1. 1 squared is 1. 1 plus 3 is 4. Last one, x equals 4. 4 minus 2 is 2. Square that, you get 4. Plus 3, you get 7. I want you to notice that when I did x equals 2, I got 0. And I told you just a few seconds ago that 0 is the most important number. 0 is the place where you're going to have your vertex. Notice that it doesn't mean that x equals 0 is where the vertex. It means whatever x value makes the parentheses equal 0. This is such a crucial idea that the vertex is where the parentheses equals 0. And when I look at the parentheses, they say x minus 2. Well, how do you make x minus 2 equal 0? How do you make x minus 2 equals 0? You use x equals positive 2. That actually turns out to be the axis of symmetry. The vertex and the axis of symmetry should always have the same x value. Those are really just two ways of saying the same thing. So here is the vertex, 2 and 3. Then here are the points symmetrically above it, 1 comma 4 and 3 comma 4. And then the other 2 points are up at a height of 7. So that would be right here and right here. This is a way that I usually like to draw quadratics, is to start from the vertex and work your way symmetrically outward. And that will keep the shape the same as you move around. This graph has a minimum point. It does not have a maximum point. It goes up and up and up forever, never ending. Okay. I want you to notice that the vertex numbers were sitting right there in the equation. I'll do just one last one as an example. This one right here has a little bit more going on with the equation. Notice that there's a little typo. There's a negative right here, and there's a positive right there. Let's just make it a negative, because I think that will be a little bit more of an interesting example. So there's a couple operations I got to do. I start with the parentheses, and I work my way out. So x equals negative 5. Negative 5 plus 3 is negative 2. Square that, you get positive 4. Times negative 2, you get negative 8. plus 5, you get negative 3. Next up is negative 4. Negative 4 plus 3, negative 1. Square that, positive 1 times negative 2, negative 2, plus 5, positive 3. Next up is negative 3. Negative 3 plus 3, 0. Square that, 0 times negative 2, 0 plus 5 equals 5. Next up, negative 2. Negative 2 plus 3 is 1. Square that, 1 times negative 2, negative 2 plus 5, 3. Last up, negative 1 plus 3 is 2. Square that, 4 times negative 2, negative 8 plus 5, negative 3. Let's try to graph those dots. So negative 5 comma negative 3 is right here. Negative 4 comma 3 is right here. Negative 3 comma 5. Negative 2 comma 3. Negative 1 comma negative 3. That time I didn't progress from the vertex outward, just to show you that although that's a nice method, you don't need to do it that way. The vertex is negative 3 comma 5, which of course you can predict and see just from the equation. There's the negative 3. There's the positive 5. The axis of symmetry is x equals negative 3. I'm going to clarify again. I just drew an arrow from something that said x plus 3, and I said the words, there's the negative 3. Because if x plus 3 equals 0, guess what? X equals negative 3. I'll say it one more time. 0 is the most important number, and the vertex is where the parentheses are equal to 0. Last one, just to clarify, how can you know just by looking at an equation if it will have a minimum or maximum point? Well, that example had a maximum. Forgot to circle that. That has a maximum. This has a minimum. This has a minimum. And I noticed that this is a positive x squared graph. This is a positive x minus 2 squared plus 3. This is a negative. And that's the whole idea, that you will have a minimum if there is a positive x squared. You will have a maximum if there is a negative x squared. How can you know by just looking at the equation what the vertex is? You're going to look for x minus a number squared plus the other number. And how can you know by looking at an equation what the axis of symmetry is? By looking at the x minus a number. Remember that it's whatever number makes the parentheses 0. So when I write x minus h, that is telling you that the opposite of what number you see in the equation is where the vertex is. Just like when I saw x plus 3, I told you that means x equals negative 3 is the vertex, because minus a negative is the same as a plus. So thanks for watching. Please comment or ask questions if there's anything. Happy to do more examples if you want. I just didn't want the video to go on forever.